Hello students, welcome to the maths class. Today I am going to explain a new chapter, differentiation. This chapter is not very new for you because you have studied this chapter in class 11th. But in class 11th, in this chapter, you studied only some points. Means to a limit you studied this chapter. You found the differentiation of polynomials and you found the differentiation of trigonometric functions, and you found the differentiation by using first principle. So first of all, in second exercise, here in class 12th, you are going to study the same differentiation which you studied in class 11. So that's why here I have written recapitulation of work done in class 11th. Means whatever you have done in class 11th. So in short, a revision of that work will be taken in this exercise 8A. So you see what you have studied one time, you revise. First point, differentiation. The basic results and rules of differentiation include d upon dx of c. D upon dx, it is the differentiation sign. D upon dx means differentiation with respect to x, and c is constant here. So differentiation of constant is 0, I told you, and here you have to keep in the mind where c is a constant. So here example you can see d upon dx of 3 equals 0. Any constant term will be there, then its differentiation will be 0. Now second part in this, they are taking d upon dx of fx plus c. Fx means function of x, one function of x will be there and one constant term will be there. So for constant term differentiation will be 0, so it can be written as d upon dx of fx. Because for constant term differentiation will be 0, so directly you can write d upon dx of fx, and it can be written as f dash x. Differentiation of fx can be written as f dash x, like this, d upon dx of fx equals f dash x. D upon dx of fx, one more time I am writing, d upon dx of fx equals f dash x. You have studied in class 11 this thing. Next, here example they are giving d upon dx of x to the power 6 plus 8. So for 8 differentiation will be 0. For x to the power 6 it will be 6x to the power 5. Next rule is coming. Before this you see second rule, d upon dx of x to the power n is not equal to 0. Keep in mind, in class 11th also I told you n is not equal to 0. The power should not be 0, because if power is 0, this power is 0, so it will become a constant. X to the power 0 means 1. The power 0 of any number except 0. The power 0 of any number except 0 is always 1. The power of x is any number except 0, then it will be 1. So n x to the power n minus 1. If like this differentiation you are making, so n will go back and power of x will be 1 less. So n x to the power n minus 1. So here you can see d upon dx of x to the power 9. So 9 x to the power 8, 1 less power. Now you can see here in previous example, d upon dx of x to the power 6 plus 8. So d upon dx of x to the power 6 will be 6x to the power 5, and for 8 d upon dx I already told you it is 0. Next example, next they are taking the second, d upon dx of ax plus b to the power n. So ax plus b to the power n, in the mind you have to take ax plus b as x to the power n. So x to the power n, you know, n x to the power n minus 1, n x to the power n minus 1. because now x you took in the mind. So in place of x you have to write ax plus b, because you were considering ax plus b as x. So n ax plus b to the power n minus 1. Not, don't write n x to the power n minus 1. If you are writing, then in place of x you put n ax plus b to the power n minus 1. So like this you can take. Now example you can see d upon dx of 3x plus 5 to the power 4. So 4 into 3x plus 5 to the power 1 less 3. When you see, and one more thing is will also come, and 3 also they are giving here. I did not tell you, I think. So you see n ax plus b to the power n minus 1 into coefficient of x will be in multiplication a. Why it will come, I will tell you. I told you that time also, chain rule is there. It is the chain rule. One more time I will tell you. Later I will tell you this concept will come, chain rule. Here you can remember, if you are differentiating a linear polynomial, you can say ax plus b, so its power will go in back, means like linear polynomial you can take as x, and x and x to the power n minus 1, then coefficient of x will come in multiplication. You can see the example here. You can see this is the example, d upon dx of 3x plus 5 to the power 4. So 4 into 3x plus 5 to the power 3, but coefficient of x is 3, that is coming in multiplication. So 3 4s are 12, 12 into 3x plus 5 to the power 3. So linear function of x to the power n equals n into linear function to the power n minus 1 coefficient of x they are giving. Don't forget to multiply by the coefficient of x. Special case they are taking, d upon dx of x is 1. You have to learn, I told you that time also, because 1 to the power 1 you can apply this formula, d upon dx into x to the power n minus 1 equals n x to the power n minus 1. Here power is 1. So when power is 1, then 1 into 1 minus 1 x to the power 0, 1. So in the same way you can see in this table, you have to learn d upon dx into d upon dx of x equals 1, d upon dx of 1 upon x equals minus 1 upon x square. You can use that d upon dx of 1 upon x can be written as x to the power minus 1, and you can apply the formula d upon dx of x to the power n minus 1 x to the power n minus 1. N is minus 1 minus 1, so minus 2 will come, minus 1 into x to the power minus 2, so minus 1 upon x square you can write. So by using this formula which I told you just before, you can find this. But if you learn it, so it will be easy for you, because many times in long questions 2 times 3 times you are applying this formula. So again and again if you write like this, then it will be difficult, it will be time consuming. So if you learn, if you are taking differentiation of 1 upon x, then directly minus 1 upon x square you have to write. Next is d upon dx of under root x. You have to learn directly 1 upon 2 under root x. X should not be 0. D upon dx of under root ax plus b equals 1 upon 2 into under root ax plus b into a, again coefficient of x in multiplication. You have to keep in the mind, because you are considering ax plus b as x. So d upon dx of under root x. So just before you have studied 1 upon 2 into under root x, you have written 1 upon 2 into under root x, but it was not x. So coefficient of x will come in multiplication. I told you in class 11, one more time you see. Next, third, d upon dx of c fx. C fx means one constant and one function of x. So constant will go back and f dash x will come. Means one example you can see here, it is written d upon dx of 5x to the power 8. So 5 will go back, 5 d upon dx of x to the power 8. Like this you can write. Now x to the power 8, what it will be? 5 into 8 x to the power 7. So it will come 40 x to the power 7, you can see. So like this you can do. Next, for trigonometric functions you have studied. For sin x, differentiation is cos x. For cos x, differentiation minus sin x. For tan x, sec square x. For cot x, minus cosec square x. For sec x, tan x. For cosec x, minus cosec x cot x. I told you that trigonometric function starting with their differentiation is negative. You see cos starting with so its differentiation is negative. Cot starting with its differentiation is negative. Cosec starting with its differentiation is negative. So like this you can learn. In class 11th you have studied. One more time you remember. Now next, it is remark you keep in the mind, x is in radian in all the above cases. Whatever value of x is an angle, but this angle is in radian. You have to keep. Next is fifth, derivative of algebraic sum of two functions. It is very easy. If sum of two functions is given, then separately derivative you can take. You can see the example here. If y equals u plus minus v, so dy upon dx equals du upon dx plus minus dv upon dx, means separate differentiation can be taken. So here y equals, example is there, y equals 5 tan x plus 3x to the power 7. So dy upon dx, both the side differentiation you do 5 tan x. So 5 tan x, you can take 5 d upon dx of tan x plus 3 d upon dx of x to the power 7. Like this you can take. So separately, if sum is given or difference is given, so differentiation can be taken separately. For separate term, separate differentiation can be taken. Generalization they are giving means if more than two terms are there, u plus minus v plus minus w plus minus and so on. So like this you can take. Four terms are there, you can see example, y equals 8 plus 7x plus 9 x to the power 4 plus 6 sin x plus 8 cosec x. So they are taking for this differentiation, for 8 0, for 7x 7, and for 9x to the power 4 36x cube. So for all the terms separately differentiation they are taking. So just before I told you. Sixth, product, very important rule. Differential coefficient of product of two functions. In class 11th it came uv, y equals uv, then dy upon dx, u same, differentiation of v plus v same, differentiation of u, this. So you can see here two functions are given, example, y equal x cubed sin x. So x cubed same, differentiation of sin x, you can see here, plus in between plus will come, sin x same, and differentiation of x cube, means first function then differentiation of second function plus second function and differentiation of first function. It is given and you have to write differentiation. Expansion of this rule, if three functions are there, u v w, then differentiation of one function and product of remaining function. So first and second function product, differentiation of third function, plus first and third function and differentiation of second function, plus second and third function differentiation of first function. Like this you can extend this rule. If function n functions are given, then you can write like this, 5 functions, 6 functions, 7 functions, then you can extend this rule. Differentiation of one function and product of the remaining function. Like this you can produce this. You can see they are giving, the rule can be extended to the product of any finite number of functions, derivative of the product of finite number of functions, sum of the products obtained as under derivative of a function, product of the remaining function, plus till all the functions forming the product have been differentiated. So like this you can produce. Example is also they are giving 1 2 3 functions they are giving, you can see. So first second and third function, four functions are giving: x cubed first function, sin x second function, 2x plus 7 third function, x minus 9 to the power 8 fourth function. So three function product: sin x, 2x plus 7, x minus 9 to the power 8, and differentiation of first function x cubed, plus you can see now first second and fourth they are same and differentiation of second function. Now first second and third are same, sorry fourth are same, differentiation of third function. First second third are same, differentiation of fourth function. So all four function differentiation you have included. So till here it will be ended. Now you can differentiate separately. So it will be the answer. This is given: sin x 2x plus 7, x minus 9 to the power 8 into 3x square plus x cubed into 2x plus 7, x minus 9 to the power 8 into cos x plus x cubed sin x into x minus 9 to the power 8 into 2 plus x cubed sin x into 2x plus 7 into 8 into x minus 9 to the power 7. Now after simplification you will get this last step. After the seventh, this rule also very important, you have studied: derivative of quotient of two function y equals u upon v, then denominator square in denominator you will take, and in numerator denominator same means v same, differentiation of u minus, this time minus will come in between, v same differentiation of u minus u same differentiation of v. So you can see here one more time: v same differentiation of u minus u same differentiation of v upon denominator square. So they are giving in English words also, they are giving denominator square equals denominator into derivative of numerator minus numerator into derivative of denominator. And example also they are giving, you can see example: y equals 3 x to the power 4 upon 1 minus x to the power 7. So 1 minus x to the power 7 whole square, because denominator square you have to take. Now in numerator denominator same, 1 minus x to the power 7 multiplied by derivative of numerator d upon dx of 3x to the power 4 minus 3x to the power 4 numerator same, and derivative of denominator d upon dx into x minus 1 minus x to the power 7. Now you can simplify and you will get this answer, final answer: 12x cubed into 1 minus x to the power 7 plus 21x to the power 4 into 1 minus x to the power 6 upon 1 minus x to the power 14. Now reciprocal rule, this rule also you can see: if d upon dx of 1 upon x means you can apply this u upon v formula also in this case, but in this case u and v, in previous case I told you u and v are the functions of x. Here in numerator 1 is given and in denominator function of x is given. So you can apply that formula also, u upon v, or if you don't want to apply then directly you can write minus derivative of denominator, you can see here derivative of denominator and derivative square, sorry denominator square in the denominator. So one more time I am telling, in numerator you can write negative of the derivative of denominator, and in denominator square you can write. So this answer will come. Differentiation by first principle, very important, in class 11th you have studied. So one more time I am telling to you, whatever function is given, how can you differentiate the given function by first principle? For that I am giving the answer: put the function to be differentiated is equal to y equals fx. One example I will take: let delta x or h be an increment in the value of x, then delta y will be the corresponding increment in the value of y, and y, so that y plus delta y equals f x plus delta x. Find delta y. and subtracting 1 from 2. So you will get like this, delta y equals f x plus delta x minus fx. Now divide both the sides by delta x and take the limit. Dividing both the sides by delta x, take the limit both the sides, delta x tends to 0. So delta x tends to 0, delta y upon delta x, it will become limit delta x tends to 0. With this it will become this full, which I am making circle. So this will become dy upon dx. So dy upon dx or f dash x equals limit, it will be RHS, delta x tends to 0, f x plus delta x minus fx upon delta x. In place of delta x, h can be taken. Now you can see some example. One example is in front of you. Y equals x cube plus 3x square plus 5. By first principle you have to find the derivative. So delta x be an increment in the value of x. So delta y the corresponding increment in the value of y. It was means you have done this thing in class 11th. So one time you see y plus delta y equals x plus delta, wherever x is there in the given function, in place of x you have tried delta x. So x cube is given, so in place of x cube, x plus delta x whole cube plus 3x square is given, 3 into x plus delta x whole square plus 5. Now it is second equation, it is first one, you can subtract first from second. So delta y will come in LHS and second RHS minus first RHS. So finally you will get 3x square minus 3 plus 3x into delta x plus delta x square plus 6x into 3 delta x dy upon delta y upon delta x. Now take the limit. When you take the limit, so this LHS will become dy upon dx, I told you. So and in RHS when you take delta x tends to 0, so you can take this, in place of delta x you can put 0, 3x square same, 3x into delta x, so delta x 0, delta x square 0, 6 into x it is coming 3 delta x, 3 into 0. So finally answer is coming 3x square plus 6x. This is the derivative of the given function by first principle. First principle like this also you can use. This work can be done as under, directly you can write by using first principle. By using first principle it is necessary to write f dash x equals limit h tends to 0, f x plus h minus fx upon h. In place of delta x I told you, you can take h. So in the function wherever x is there, in place of x you can put x plus h. So x cubed means x plus h whole cube plus 3x square means 3 into x plus h whole square plus 5. So this is first one, f x plus h. This one, this is the value of f x plus h minus, this is minus, in the formula it is given, fx, this is fx upon h. Now s tends to 0 you have to take already. Now you simplify. When you simplify you will get this one, 3x square plus 3x into h plus h square plus 3h plus 6h. Now h you can take 0 because limit h tends to 0. So you will get 3x square plus 6h. So like this you can solve all the questions of exercise 8a. In exercise 8a, I'm telling to you, which I told you just now, all the rules which you have studied in class 11th, rules of differentiation. Then what will the differentiation of x to the power n, what will the differentiation of trigonometric functions, and what is uv rule, what is u upon v rule. You learn these things, you keep these things in the mind, then easily you can do all the questions of exercise 8a. It is very easy exercise, and by first principle some questions are given in exercise 8a. So with the help of example which I explained, you can do those questions also. If you have any doubt, then you can ask in comments, then I will clear your doubts. So thank you and have a nice day.